All right, hello guys. This is Mr. Lee again. I'm going to be going over the virtual lab that we did, kind of speak about some of the nuances, some of the minor details that some of you may have missed. Remember, measuring instruments accurately, using measuring tools accurately is a big part of science. So we got to be sure that we know how to do this properly. And, trying to incorporate some of our definitions and vocabulary into it as well, so that when I speak of it in a future date, you will kind of understand what I'm talking about and what I mean by it. So I'm going to be sharing my screen, and we're going to do something similar where I'm going to draw on the screen. I was going to print it out and write it, but couldn't do that. So we're going to use this system. So we're going to look at number one. Number one was looking at two burettes. Now, if you don't know what a burette is, just open a new tab, type in Google burette real quick, right? So the difference about a burette is you're pouring in from the top, which you usually do for any glassware, but you're releasing from the bottom as well. Okay, so you're not pouring out from the top, you're releasing to the bottom. So how the numbers system actually works, if you notice properly, is that it's actually going higher when you move down. So the 0 mark is at the top of a burette, because that's what you fill your liquid up to. And what the number starts increasing, because once you start releasing the liquid from the bottom, the water level will drop, and the amount that it drops will be considered the, did you need something?
I have a tennis kid looking for you. Like, she doesn't know where to go.
Outside, tennis courts.
Like the court?
Yeah, tennis courts. All right, sorry. So as you can see, it's going downwards from 0 to whatever it goes to, right? So here we see a 24 to a 25. Here we go from a 40 to a 41. They're both getting higher when they're going downwards. Okay. Now let's move on to reading instrumentations. Okay. So here's a vocabulary. So hopefully we realize that each tool will always have the same amount of last digit places, meaning, and here's what I mean, right? So if we look at a tool, the smallest increment doesn't change, obviously, because that's that tool. So on the burette A on the left side, the smallest increment that we have, these are our 0.2s, right? Because the next one is 0.4. It's not 0.4, but it's going in increments of 0.2s. That is our smallest increments. Now, because it's skipping a number, what that means is we don't know exactly what it is, because it could be in between. It could be in between 0.2 to 0.4. So because we aren't for certain what our 10th place is, this is now our uncertain position. And from what we discussed, every single measurement can only have one uncertain digit, right? Because we can only guess once. There's another term for this, for uncertain. It's called imprecise. Right? If you're imprecise, that means you're not really sure about it, right? It's not too close to each other. So another way to say about this is the imprecise digit is the 10th place. So what this means is that there's a capped number of sig figs that these instruments can have, right? No matter what number you have, it will always end with one decimal place, the 10th place, because that is the limitation for this instrument. We can't get any more details than that. And we can't get any more precision compared to that. Now, why do we call this precision? Recall the definition for precision, right? Preciseness is how close the values are together. So if you give this instrument to someone and you tell them to guess that 10th place, they can only guess between 0.2 to 0.4. I guess here it's 0.0 to 0.2, right? So they can only guess between a range of 0.2. But let's assume that we look at another instrument. I'm gonna just draw a ruler that from the example that we did, it goes from 0 to 10, and these are going by ones. 3, right? Well, actually, that's a bad example. Let's just say it goes from 0 to 10. I'm going to undo this. Let's just say it goes from 0 to 10, and we don't even have these little tick marks. So let's just say it's a yardstick that goes by tens, right? $10, $20, $30, right? And it just goes on and on and on and on, right? Let's say we're trying to get a measurement from this ruler here that's going by tens, okay? Well, if it's here, we can guess that it's between 0 and 10. So what that means is if we give someone a measurement and they're trying to estimate how long this object is, any value between 0 and 10 is potentially correct because there's no indication on any more precision, any more information to make it a more accurate number. So what that means is someone can guess 8, someone can guess 9. It's not dependent. Right, these could all be correct. Now, if we look at it now, the range that they can guess between is 0 to 10. That's a whole 10 difference that they can have a guessing difference based on just how they perceive the reading to be. Because there's nothing else that gives them additional information. 0 to 10 would work properly. The other instrument where it's more detailed, where there's a smaller increments, has only a difference of 0.2 difference in between the guessing that can do. So that is why we call these instruments, the one that has a more detailed incrementation or smaller incrementation, they're more precise because the measurements that you're going to guess are that last digit that you're going to guess is going to have a less impact. It's going to move around a lot less. Hopefully that makes a little bit of sense to you guys. If that doesn't, do let me know and I can try to re-explain that to you. So that's what we call a more or less precise instrument. A more precise instrument means there's a smaller incrementation in between the measurements. Means the more decimal places we have, the more precise that instrument will be, because the guessing work will be at a further right side of the decimal place. The further right you go to the decimal place, the less impact it'll have, right? A change from 0.001 to 0.002 is a lot less than a change going from to it'll be a lot less than going from a change from I need to erase all this stuff. There's too much junk. From let's say 1 to 2. Right? So this is going to be less of a change. Let's have an intermediary. So let's go from, let's even erase 1 to 2. 0.01 to 0.02, right? And obviously from 1 to 2, it'll be even more greater difference, right? So that's what we mean by a more precise instrument, more precision. When the instrument allows us to have more decimal places, because the guesswork on that last digit will impact the overall measurements the least amount or lesser amount, right? So the more measurements you take with that instrument, the closer the values will be, right? Because as I just mentioned, a difference from 0.01 to 0.02, which you might measure next time, is not that big of a difference. Whereas if you measure a 1 and you measure a 2 next time, that's a big difference. Right. You can imagine how if we go to like a bigger scale into like thousands of meters or kilometers, right? 1 kilometer to 2 kilometers is a big difference, right? If you're trying to estimate the distance of, let's say from your house to I don't know, Paris. If you estimate from here to Paris, 1,000 or 2,000 kilometers isn't a big deal, but in terms of that distance, but it's still pretty imprecise if you're estimating and your value is differing by that much. Hopefully that makes sense. If not, I can go over it at a future date in a different video as well. But I do want to go over the rest of the lab. And I mentioned this is just to we understand what preciseness really means in terms of how we grade instrumentation. You'll hear this a lot, that your measurement was imprecise, or this tool is imprecise. It just means that it's giving us less decimal places. We have less information to work with, so we have to kind of guess at a higher place in the number. Right? We have to guess the ones place or the tens place. So going with this, then the only trick with the first question was that it is a burette, so you have to read down. So this is actually going to be between 40, that's a 40, and between 40.2. These are in between these two. So your answer is in between. Answer in between. All right. Now we can't know it's 40.0 or 40.2 because there's no tick mark at 40.1. We can't know if it's 40.1 or 40.2 or 40.0. We have to assume that. So that that tenths place decimal is the guess digit. So any answer you have between, let's say an example of 40.1 would be fine as long as you had one decimal place in there, right? Because I do see it's kind of in between. So that's the best that we can do. If you do 40.05, that is incorrect because we don't know that tenths place. There's nothing here that tells me it's 40.1, right? Or less than 40.1 at least. For the second one, similar situation. It seems like it's between 24.2 and 24.4. Right, so these are these two values. And again, we're reading down, so the number's actually increasing when we go down. So any answer between the two would work. Answer between the two. Okay. So if you gave me 24.3, that would be best estimated answer. There's no more additional information that we could have gleaned from this instrument to tell us any more. We can't guess that hundredths decimal place because we're already guessing the tenth place, right? We know it's between 0.2 and 0.4. There's nothing that tells me it's 0.3, less than 0.3, or more than 0.3. Right? We have to really look at, do we know for sure it's this number in this instrument? So that's the trick from part one. Let's go over to part two. Let's see. This is an Erlenmeyer flask. So I'm gonna go a bit more faster because it's pretty much the same idea, but with a new instrument. I don't think there's anything new here, except the increments for this one is going by, I believe, 50s, right? So this is 150, this is 250, and this is 350, right? Here it's going by 25, so 125, 225, and all that good jazz. So if we look at the measurement on the left, this is a normal reading where it's going from low to high, from bottom up. Okay, so from me, it seems like it's between 300 and 350. So it's in between. Now, what digit can we guarantee? What are we certain about? What is precise about this measurement? The 3 is. We know it's at least 300. So that hundredths place is guaranteed. This is certain. I can't write. Hello? This is certain. Okay. Now, can we be certain about the tens place? I would argue no. Why? Do we know it's 310? Do we know it's 320? Do we know it's 340? There's no other information from this instrument that tells me what the information about the tens place is. So here we're actually having to guess or having to estimate what the tens place is. So now this digit is our estimated. So I'm gonna here estimate, it's a little bit, I can't see, I think it's less than that, so I'm gonna just assume it's 340. Okay, this, it's not calibrated correctly. It's horrible. Oh my goodness. So now this digit in this measurement is our estimated. Now you might be like, Mr. Lee, but there's a zero there. Well, remember our rules for sig figs. Trailing zeros without a decimal is not significant. So this has two significant figures. This number has two sig figs. The 3 and the 4 are the significant figures, right? We still count that uncertain or guessed digit. And we're going to say that this instrument is less precise at measuring the volume of liquids because we can guess between 300 and all the way to 350. There's a difference of 50 instead of the previous one. It's a difference of 0.2. Right? All we knew was between 40.2 and 40.4, or 40.0 and 40.2, I believe that was. Whereas here we know it's between 300 and 350. It's a very big, wide difference. Right? It's less precise. The numbers from this Erlenmeyer flask will have a greater range if we're all trying to guess it. Same idea applies to the one on flask B, right? We know it's between 150 and 175. So it's 150 to 175. So it's between somewhere there. I think it's closer to the top. So I'm going to guess that it's 160. Or let's just guess 170. It's closer to the 170 mark. And remember, this is our certain one because we know it's in the 100 range, right? So this is certain because the instrument tells us it's in the 100 range, but we don't know if it's a 7, right? The next digit down, the next tick mark down is a 5 in that place. The tens place is a 5, and the next one is a 7. So we have to guess whether it's between 5, 6, or 7. And I'm going to guess it's 7, and that last zero is insignificant. So this is estimated or guessed. And this is not sig fig, not significant. I'm just gonna write sig, not sig for not significant. So there's also two sig figs for this answer as well. You do the same thing for the next couple of measurements. I'm just gonna give you the answer for this. If you do not understand how I'm getting it, then you can ask and I will explain it during tutorials, or just send me an email. You can, but the video will turn too long if I spend my time here explaining it. So I'm going to just scroll down for next problem. This one. Running back and forth because I need to fix this thing. Okay. So this one, I can see it's kind of hard to read. So I think the lowest point is between this tick mark and this tick mark. So it's 50. These are going by 1. So I think it's 50 points. This is 1, 2. It's between 50.2 and 50.3. So I think it's 50.25. Okay. This time this is the guess digit. This is the guessed. I know I'm saying guess and estimated differently every single problem, but you guys know the idea. All right, we know it's 50.2 for sure, and it's between 50.2 and 50. Did I actually do that wrong? Yes, I drew it. 1, 2. Yeah, so it's between 50.2 and 50.3. Okay, so it's 50.25 is what I'm going to say. If you did anything between 50.2 and 50.3, you're correct. 4 sig figs here. On the right, it's a bit less precise. Now that's where the issue comes in with our lab a little bit. Wait, actually. Oh, my bad. I'm sorry. I made a mistake. See, so you gotta be very careful about reading these measurements. I did not see that this top number was a 60. That's my bad. I forgot. So these actually are going by 1. So this is 51, 52, 53, and all that stuff. So we know it's between 52 to 53. So I'm going to guess that it's 52.5 because it's between. So this is our guess digit, the tens place. Okay. All right. Ooh. Next one, now that we have 3 sig figs for this, on the right one, we know it's between 35 and 40. So each of these is, let's see, 1, 2, 3, 4, 5. So there's 5. Each of these is ones. All right, so there's 36, 37, 38, 39, 40. So now we know it's between 36 to 37. So we can guess it's 36.5. Right? Anyone between those two is fine. This is our estimated. Okay. Last two. I'm gonna pull both of them up right here so that we can see both. I can work on them real quick. Okay. This one is a doozy. Okay. Had a lot of people have issues with this. This is the same idea as earlier. We have to look at what's guaranteed. I'm gonna argue that it's at 600, but let's for the sake of this problem, say it's below 600. All right. If you think it's on 600, it's fine. But let's say for the sake, it's below 600 for now. Okay. So if it's below 600, I know it's between 550 to 600, not 5. Not 6. All right. So if it's like this, then we know for guaranteed that it's the hundreds place is a 5. This is certain. We know this for a fact because we're saying it's below 600. We know it's at least 500. Then do we know the tens place? Well, from this instrument, we don't. We don't know if it's between, if it's 6, 7, 8, or 9. Right? It could be 560, could be 570, could be 580, 590. We don't know for sure. Or you might be like, oh, but it's closer to the top, but we don't know for sure. There's no, like the instrument does not give us an increment that allows us to guarantee that digit. So this tens place will now be guessed. I'm going to guess it's 9. Okay, this is the closest thing that I have to 600. So because this is our guess, our estimated, that's it. We cannot estimate anymore. So our ones place has to be a 0, and that becomes insignificant or not significant, not insig or not significant. So this has 2 sig figs for the answer. Okay. If this was 600, how would I answer that? Because if I write 600, that would actually have 1 sig fig, right? But if I put a period or a decimal after it, now this would have 3 sig figs. So if you did think it was exactly at 600, how would I represent that while notating how the preciseness of this instrumentation is, right? The preciseness meaning it only is able to guarantee the hundreds place and we're estimated tens place, right? Because the number, our measurement tells us what we know for sure and what we're guessing. Okay? So how we would actually do this is via scientific notation. You know this, right? We learned this. So scientific notation wise, you do, and this is why it becomes important to know scientific notation. Sometimes we need to do it like this. It's 6.0 times 10 squared, right? 6 times 100, 600. Here we have 2 sig figs because this 0 is a trailing 0 with decimal. This is now significant because it's trailing with a z decimal there. So now this has 2 sig figs and it represents 600. So if you think 600 was the correct answer, this would be the way to go. For the one on the right, it's much easier to read. We know it's between 40 and 50. So you can guess 48, right? 2 sig figs, easy peasy. So that could be your answer for there. And I'm not writing units for any of these problems. I'm just trying to get through how to get the actual numbers. Make sure you are writing units. It is very important. Last problem. This is actually a kind of if you kind of realize they're both the same thing, except this starts at the beginning of the meter stick and this is the end of the meter stick. They both go by point ones, right? So this is 5.1, 5.2, 5.1, 5.2, 5.3. So what that means is we can guarantee the 10th place. So if we look on ruler A, we know for sure it's between 41.6 to 41.7. You know for sure it's between the two. So we can get, and we know it's less than 41.7. So we can estimate it's 41.6, and let's say it's directly in the middle, so it's 41.65 centimeters, right? The right one, we know it's between 5.1 to 5.2. Now, for me, it seems like it's a little past 5.1, but it's not past 5.2, obviously. So I'm going to assume it's 5.11, right? Because it's like right after the 5.1. So this will be our answer. Notice how our last decimal place is the same on both, because we can call this, they have the same precision. Both these instruments have the same precision because we're only estimating the hundredths position in the decimal place for both of these instruments. We call them the same precision. Now, the issue comes with, obviously, now they have different number of sig figs because we have to go to the second decimal place. This one only has 3 sig figs, whereas the one on the right has 4. So someone who came up to me with the question for this, there was one student, you will get bonus points. I do like people thinking outside the box and finding things like this. So keep it up. This is one of the tough ones where you need to realize that it is sig figs. All right. If you have any questions on anything I went over, please ask. I know I kind of went fast, and this is a video, me talking to a camera. I may miss some things. My handwriting may suck. I'm still trying to learn how to do this better. All right. Other than that, I have to go. Peace out, guys.